Section 1.5, Part 1, Solving Linear and Compound Inequalities. The first thing you need to know is that when you're solving linear and compound inequalities, it's very similar to when we were solving just basic linear equations, which we did back in 1.1. So you're going to find that we're doing something very similar. The difference is, obviously, we're not going to have an equal sign. We're going to have an inequality symbol. So we could have a greater than, a less than, a greater than or equal to, or a less than or equal to. So that's what we're talking about when we have an inequality, one of those inequality symbols. The difference between solving a regular equation and a linear inequality is that if you multiply or divide both sides by a negative, you have got to flip the inequality symbol. Okay, and you're going to see that in some examples. That is the big thing. Make sure you flip the sign. All right, once we figure out how to solve just basic linear inequalities, we're going to jump to compound inequalities. There's two types of compound inequalities that we're going to deal with. Or problems and problems, okay? Or is the union of the two intervals, so it can be one interval or the other, okay? Both pieces are the solution. And would be the intersection or the overlap of the two intervals. And you'll see that when we get to the examples. Example 1, solve and then graph the inequality and write the solution in interval notation. So we're going to focus on solving and graphing first, and then we're going to be able to figure out how to write our solution in what we call interval notation based off the graph. So you're going to learn interval notation as we go through these examples. Okay, so think of it like an equation, all right? Pretend like this is like an equal sign in the middle, but we know it's a less than sign. So solve as you would a regular linear equation. So the first thing I'm going to do on the left-hand side is I'm going to distribute. I'm going to distribute the 4, which leaves me with 4x minus 16 is less than, I'm going to distribute the 3 on the right-hand side, 3x minus 15, okay? As I did with regular linear equations, what I'm going to do is I want to get the x's on one side and the constants on the other. So I'm going to move this 3x to the left-hand side by subtracting it from both sides. Okay, so that gives me x minus 16 is less than negative 15. Okay, those cancel out. Again, trying to isolate the x, so I'm going to add 16 to both sides. Add 16 to both sides, and I have x is less than negative 15 plus 16 is 1. Okay, so that's my solution, but that's not interval notation yet. So let's graph it first. I'm going to graph up here. Okay, so when we're graphing this, I like to just draw a few numbers on my number line. So here's positive 1. Here's 2. Here's 0. So just a couple numbers around the number we're looking at. Now, if you remember, we used to do an open dot and a closed dot when we did our graphing. Now, an open dot, we're going to use a parenthesis, okay? We're going to use parentheses. And when we're dealing with what was a closed dot back in the day when you were graphing, we're going to use brackets instead, okay? So it's very similar to how you used to graph on a number line with open circles and closed, but now we're going to use parentheses and brackets, okay? So x is less than 1. All right, since this is strictly less than, it's not equal to, we would use the open circle, which is equivalent to the parentheses. Less than 1, so I'm going to show you how that works. Less than 1, so I'm going to put a parenthesis at 1, and I'm actually going to face it to the left because I want to include all of the values less than 1. Okay, 1 and everything less to it, not including 1. Okay, so by graphing it, that helps us to write it out in interval notation. So the solutions to this inequality are all of the values less than 1. So everything up to 1, but not including 1. How do I write that in interval notation? Well, I start with the lowest value. So all the way to the left would be negative infinity. So this graph goes all the way from negative infinity to 1. Okay, the left-hand side goes from negative infinity all the way up to 1. 1 gets a parenthesis, okay, because we have a parenthesis in the graph. 1 is not included. And our infinities, negative infinity and positive infinity, are always going to get a parenthesis, okay? Because they're not an actual number that can be included. So my solution is negative infinity to 1. Example 2. Again, we're going to solve and graph and then write our final solution in interval notation. Okay? So again, we're going to pretend like this is just a regular equation. So the first thing I always want to do is I want to get rid of fractions. Okay? And right now I have this 3/2. So to get rid of fractions in a problem, you multiply by the common denominator. In this example, 2 is my common denominator, so I can multiply every term by 2. So I'm going to write it out, show you what I'm doing. Okay, every term by 2. So 2 times 9x is going to give me 18x. 2 times 6 gives me minus 12, is greater than or equal to. 2 times 3/2 x is going to give me 3x. And then lastly, 2 times 9 is 18. Okay, so I've eliminated the fraction. Now I can solve this just like the last example. I want to get my x's on one side, my constants on the other. So I'm going to subtract 3x to move this 3x to the left-hand side. Now I have 15x minus 12 is greater than or equal to 18. All right, now I'm going to add 12 to both sides. That leaves me with 15x is greater than or equal to 30. And my last step would be to divide both sides by 15. Okay, so x is going to be greater than or equal to 2. So again, graph it, and then we can easily write our solution in interval notation from the graph. So I'm going to put 2 on here, a 3, and a 1. So a couple numbers surrounding it. Greater than or equal to 2. So remember, that's going to be a bracket. Greater than or equal to 2 would be all the numbers 2, 3, 4, and so on, and everything in between. So I'm going to have a bracket at 2, and I want every value to the right of 2 to be included. Okay, so everything greater than or equal to 2. So I'm going from 2 all the way up to infinity. Now this time, my number gets a bracket because it is included. I have greater than or equal to. My infinity, if you recall, always gets a parenthesis. So 2 to infinity. In example 3, we're going to see our first compound inequality. So it says solve the inequality and write the solution in interval notation. So notice it doesn't say we have to graph it anymore, but sometimes that helps us to get it into interval notation. So with a compound inequality that involves an or, we have 2 separate inequalities and we can solve them separately. Okay, so the first inequality, 3x minus 2 is greater than 7. Solve it just like we did in the past. So I'm going to add 2 to both sides. That leaves me with 3x is greater than 9. Then I'm going to divide 3 on both sides. So I have x is greater than 9. So that's one part of my compound inequality. So again, a compound inequality is taking more than one inequality and combining them. All right. So we're going to solve this other one. 2 times the quantity 1 minus x is greater than or equal to 1. So I'm going to distribute the 2 first. So 2 minus 2x is greater than or equal to 1. Again, I'm trying to get x by itself. So I'm going to first subtract 2 from both sides. That leaves me with negative 2x is greater than or equal to 1 minus 2 is negative 1. All right, and then notice my last step is to divide by negative 2. Divide by negative 2. So I'm going to put a little note here. We are dividing by a negative. When we divide by a negative or multiply by a negative, that was the first note I gave you guys, you have to remember to flip the inequality sign. So now on the left-hand side, I'm left with x, but instead of having greater than or equal to now, I'm going to have less than or equal to. I have to flip the inequality. All right, negative 1 divided by -2 is going to leave me with a positive 1/2. Okay, so I have x is greater than 9 or x is less than or equal to 1/2. So again, I like to graph it just to kind of see what it's going to look like. Okay, so we'll say 1/2 is here. And let's say 9 is way over here. Okay, so let's simply graph x is greater than 9 first. X is greater than 9, remember, it's going to get a parenthesis, and it's everything to the right of 9. Okay, from 9 to infinity. Now, to graph x is less than or equal to 1/2, that's going to receive a bracket. And it's going to be everything to the left, everything less than 1/2. Okay, and an or is the union. Okay, it's both of those pieces. And here's how we write that. So let's look at how we would write this first piece. Everything less than 1/2 would be from negative infinity to 1/2 with a bracket. And then we use a little u for union, okay, meaning or x could be greater than or equal to 1/2. And we write that as parenthesis, greater than or equal to 9. Parenthesis 9 to infinity. Okay, that is my solution to this compound inequality. Example 4, solve the inequality and write the solution in interval notation. Very similar to the last one, this is a compound inequality that involves an or, so we're going to solve the two inequalities separately, okay? What's wrong with this one or what's different about this one? Well, we have fractions, okay? But we know how to work with those. So here we go. The first inequality, I have a denominator of 3 and a denominator of 6. I need to eliminate the fraction. So remember, I'm going to multiply by the least common denominator. In this case, 3 and 6, the least common denominator would be 6. So I'm going to multiply both sides by 6 so you can see what's going on. Okay, 6 times 5 minus 3x divided by 3, greater than or equal to 6 times 1/6. Well, 6 and 3 reduce to a 2. 6 divided by 3 is 2. All right, these 6's over on the right-hand side cancel out. So I'm left with 2 times the quantity, 5 minus 3x, is greater than or equal to 1. All right, I'm going to go ahead and solve by distributing. So that gives me 10 minus 6x is greater than or equal to 1. I'm trying to get the x by itself, so I'm going to subtract 10 from both sides. That leaves me with negative 6x is greater than or equal to 1 minus 10 is negative 9. Okay, then I'm going to go ahead and divide both sides by negative 6. And again, little red flag. When we divide both sides by a negative, remember we have to flip the inequality symbol. So this is going to leave me with x is less than or equal to, and when I reduce negative 9 divided by negative 6, it gives me a positive 3/2. Okay, so that's the first piece. Now I'm going to go to my second inequality and solve that. Again, I want to get rid of fractions, so I'm going to multiply this entire thing by 3. Okay, I'm going to multiply the right-hand side. I'm going to write a little 3 over here so I don't forget to multiply on the right-hand side. So on the left-hand side, the 3's cancel, and I'm left with x minus 1. And then on the right-hand side, 3 times 1 is 3. I'm going to go ahead and add 1 to both sides. And that gives me x is less than or equal to 4. Okay? Now, graphing this. Let's go ahead and draw my number line, a little squiggly. Okay? So I'm going to go ahead and put 4 on there, and I'm going to put 3/2. I know 3/2 is less than 4. It doesn't have to be spaced out nicely. Okay? I'm going to graph these two pieces. The first, x is less than or equal to 3/2. That's going to be a bracket and everything to the left of 3/2. I'll make that a little nicer. Okay? Now, how do I graph x is less than or equal to 4? Well, that's also a bracket and everything to the left. Okay? And remember, this is an OR problem. So it can fall in either of these two sections. It can be less than 3/2 or less than 4. But when you look at this, notice there's some overlap, okay? There's some overlap right here. So we don't have to write these two pieces separately. In fact, we can write it as simply x has to be less than or equal to 4 only. That includes the x is less than or equal to 3/2. All right, so that means we need to only write x is less than or equal to 4 in interval notation. And so that's going to be everything from -infinity to 4 with a bracket. Again, because that will include the x is less than or equal to 3/2 values. Example 5. Solve the inequality and write the solution in interval notation. Again, we have this compound inequality, but now you can see we don't have or in between. This is actually a compound inequality that involves and. Okay? We have two separate inequalities, so just like with the or problem, we can solve them separately. So take a minute. Let's go ahead and solve both of these separately. So on the left-hand inequality, I'm going to distribute the 3 first. That leaves me with 3x plus 3 minus 2 is greater than or equal to 4. Okay? I'm going to combine like terms. 3 minus 2 is going to give me 1. So I have 3x plus 1 is greater than or equal to 4. Subtract 1 from both sides. I have 3x is greater than or equal to 3. And my last step would be to divide both sides by 3. So I have x is greater than or equal to 1. Now I'm going to carry this and down, and whatever I get for this inequality. So again, I'm going to distribute the 3. So I get 3 minus 3x plus 13 is greater than 4. Combine like terms, I have 3 and 13 on this side, so that leaves me with negative 3x plus 16 is greater than 4. I'm going to go ahead and subtract 16 from both sides to get the x by itself. That leaves me with negative 3x is greater than 4 minus 16 gives me negative 12. My last step is to divide both sides by negative 3. All right, so again, we're dividing by a negative. So that gives me x. It's no longer greater than, it's x is less than negative 12 divided by negative 3, which is a positive 4. Okay, so now let's graph this. I know it doesn't say graph, but it always helps us to write it out in interval notation. So I'm going to go ahead and draw my number line. Here's my 1. Here's my 4. Okay? Now, I'm going to graph the two pieces separately to start with, and I'm going to graph them above. Okay? So x is greater than or equal to 1 would be everything from here over. So a bracket at 1 and everything to the right, everything greater than 1. Now, x is less than 4 would be a parenthesis at 4 and everything to the left, everything less than. Okay? So I'm going to actually draw a new number line down here just so you can see. Here's my 1. Here's my 4. I'm going to graph my final answer on this graph down here. What I do for an and, remember and is intersection, okay? So that means I need the overlap of these two pieces. Where do the two overlap? Well, they first begin to overlap here at the 1. They overlap here at the 1. And then everything in between here, and I'm just doing a squiggly line so you can see it better, all the way up to the 4, and the 4 gets a parenthesis. Okay, so hopefully you can see that the overlap is all of the values, including 1, up through 4, but not including 4. So if you look at that graph, how do I write that in interval notation? Well, my solution is going to be bracket. I'm going to include the 1, and I'm going to go up to 4, and I'm not going to include it, so I need a parenthesis. That is my solution in interval notation. 6. Solve the inequality and write the solution in interval notation. Okay? This is, in fact, a compound inequality. We have a less than or equal sign 2 times in here, okay? So when you have more than one inequality symbol, it's going to be a compound inequality. But notice we don't have the keywords and or, okay? But this is, in fact, an and problem, okay? So when you have something clustered between two values, it's going to be an and problem. All right, so to solve something like this, we're not going to solve two inequalities separately. We're going to actually do it all at once, okay? So what we do is we look at the middle. We look at this 3x minus 4. And I say, okay, I'm trying to solve for x. So if I were trying to solve for x, what would I get rid of first? Well, I would get rid of this minus 4. To do that, I'm going to add 4, okay? Well, I'm going to add 4 to every piece of this inequality. So I have to add 4 over here on the right-hand side, and I also have to add 4 over here on the left-hand side. Okay, so let's rewrite what we have. Negative 10 plus 4 gives me negative 6 is less than or equal to, we see the negative 4 and positive 4 cancel out. So I have 3x is less than or equal to 14 plus 4 is 18. Okay, again, I'm trying to isolate the x, try to get it by itself. So to do that, I'm going to divide everything by 3. So again, I have to do it on the right-hand side and the left-hand side. Negative 6 divided by 3 is a negative 2, is less than or equal to x, which is less than or equal to 6. Okay, so these, you don't even have to worry about graphing. This actually makes our lives pretty easy trying to just go straight to interval notation. What this is saying is that x is between negative 2 and 6, okay? And we're going to include negative 2 and 6 because we have that less than or equal to for both of them. So my solution is negative 2 to 6, and both of them get brackets. Example 7, solve the inequality and write the solution in interval notation. Okay, so I'm going back to looking at compound inequality involving and in the other format where it was separated. Okay, so I'm going to go ahead and quickly solve these two. So again, I can solve them separately. So I'm going to distribute the 5. That gives me 5x plus 10 plus 7 is less than 2. Okay, combine like terms, 5x plus 17 is less than 2. Subtract 17 from both sides, so 5x is less than negative 15. And lastly, I'm going to divide both sides by 5. So that gives me x is less than negative 3. Okay? And again, this is an and problem. So I'm going to go over here and solve the inequality to the right. Distribute. 10 minus 6x plus 1 is less than 17. Combine like terms. Negative 6x plus 11 is less than 17. Subtract 11 from both sides. I get negative 6x is less than 6. And now I'm going to divide both sides by negative 6. Remember, dividing by a negative. Got to go ahead and flip the inequality. So this gives me x is greater than negative 1. Okay? Now, I know I flew through that one. It's very similar to one we did previously. But I wanted to show you how this solution comes out. Okay? It's a little bit different. So remember, when we're doing an and problem, we want to find the overlap. Okay? So here's my negative 3, and here's my negative 1. Let's first graph x is less than negative 3. That would be a parenthesis and everything to the left of negative 3. Okay? All values less than negative 3. Now, if I graph x is greater than negative 1, that would be a parenthesis at negative 1 and everything to the right, everything greater than negative 1. What do you notice about this problem? Well, remember an and is the intersection or the overlap. We have 0 overlap, okay? Normally we're used to the overlap being here in the middle, but it's not, okay? So I can't just write my solution as negative 3 to negative 1. Since there is absolutely no overlap, there is no solution, okay? Or the empty set. All right, there are no values that satisfy both conditions. There's no number that is both less than -3 and greater than -1 at the same time.